In this video, we will be relating the area model to the factorability of a trinomial. In a previous video, we looked at the distributive property and the product of a plus b times c plus d. Here's a plus b, here's c plus d. The area model gave us ac plus ad plus bc plus bd. Here's the distributive property, and we need to understand this property in order to look at the factorability of a trinomial. In order to warm up our brains, let's look at the product x plus 1 times x plus 3 and expand using the area model. Here's our rectangle with a length of x plus 1 and a width of x plus 3, giving us an area of x squared plus 3x plus x plus 3. Notice that the middle terms, 3x and x, are like terms. This gives us x squared plus 4x plus 3, which is the product of x plus 1 and x plus 3. Let's look at the area model and the factorability of trinomials. Can x squared plus 4x plus 3 be represented with an area model? Let's start with our rectangle and our 4 distinct areas. Place the x squared in the upper left rectangle. The only dimensions that multiply to give this is an x and an x. Place the constant term 3 in the lower right rectangle. The only factors that multiply to give us 3 would be 1 and 3. Filling out the missing areas, we get a 3x and an x. Adding up all the areas, we get x squared plus 3x plus x plus 3. This gives us x plus 1 as the length, one factor, and the width, the other factor, as x plus 3. The 3x and the x are like terms. This is our original trinomial x squared plus 4x plus 3, which is now equal to x plus 1 times x plus 3. So we conclude that the trinomial x squared plus 4x plus 3 can be represented by the area, also known as the rectangle model, and is factorable. Let's look at algebra tiles and the factorability of trinomials. Can x squared plus 4x plus 3 be represented as a rectangle with algebra tiles? We start with our t-square. Here's the tiles representing x squared plus 4x plus 3. These do not make a rectangle. Let's try a different arrangement. These do not make a rectangle. Be persistent with rearranging the algebra tiles representing the trinomial x squared plus 4x plus 3. Eventually, you will get this rectangular form, and it's arranged inside the working area of the t-square. So now the dimensions are along the top x plus 3 and along the side x plus 1, meaning that x squared plus 3x plus x plus 3, which is how the tiles are laid out in the working area, is x plus 3, the dimension across the top, times x plus 1, the dimension across the side. So x squared plus 4x plus 3 can be factored as x plus 1 times x plus 3. The fact that you could construct a perfect rectangle within the working area told us it was factorable. We conclude that the trinomial x squared plus 4x plus 3 can be represented by a rectangle with algebra tiles and is factorable. Let's look at another example. Can a squared plus 3a plus 2 be represented with an area model? Lay out a rectangle. A squared goes in the upper left-hand corner. The only two factors are a and an a. The constant term 2 goes in the lower right-hand corner. The only factors for 2 are 1 and 2. Filling out the other areas, we get a 2a and an a. This gives us a squared plus a plus 2a plus 2, which can be factored as a plus 1 along the top times a plus 2 along the side. So a squared plus 3a plus 2, because a plus 2a is 3a. This can be factored as a plus 1 times a plus 2. We conclude that this trinomial a squared plus 3a plus 2 can be represented by the area or rectangle model, and it is factorable. Let's consider the same example but look at it with algebra tiles. Can a squared plus 3a plus 2 be represented as a rectangle with algebra tiles? Lay out your t-square, and after some manipulation and some reorganization, you will find that it can be made in the shape of a rectangle in the working area of the t-square. Success! The dimension across the top is a plus 1. The dimension across the side is a plus 2. So we conclude that the trinomial a squared plus 3a plus 2 can be represented as a rectangle with algebra tiles, and as a consequence is factorable. We can go further and actually factor it. A squared plus 3a plus 2 is the factor a plus 1 times the factor a plus 2. Please proceed to the next activity in this lesson, and thank you for viewing.